Here we go. Okay, thank you very much. So thank you very much to the library for the very kind invitation. I know that in the past years there was a lineup of very prominent speakers, so I have the chance to interrupt a series of good talks. And also thank you to Sibu, and thank you to the very kind introduction. Yeah? I would like to start by asking a question. Yeah? Imagine we are 10 years from now, when the university is in the top 100. Yeah? And what is if a fantastic new theory was developed completely by an AI system? Yeah? So, for example, we could have developed a model on a quantum computer, some completely AI-run laboratory synthesized the substance, yeah? And then another AI analyzes the data, writes a paper, submits it to the journal, it is published and wins Nobel Prize. Yeah? Is that still science? Yeah? We will see. Yeah? But you know, just to jump a little bit, yeah? The danger is not, I think, that AI will make us completely redundant. Yeah? The danger that I see is that mediocrity in science will scale up exponentially. Yeah? So the difference between the two scenarios is just our good old human judgment. Yeah? So we still need to use our brain and our critical thinking in how we use all these new possible tools that pop up like mushrooms these days. So what I was planning to discuss with you today is essentially these five points. Now, first, looking around at how the scientific method, yeah, what we do daily, yeah, is a little bit reshuffling. Yeah? It's getting a little bit reorganized. We use different things of what we used just 2-3 years ago. Yeah? Then I will try to convince you that AI is a kind of a new research infrastructure. Yeah? Essentially, it's at university. When you visit a new university, you go first to the library and then to the AI center. Yeah, that's where I want to go. Yeah? I will mention, because I'm one of these quantum guys, a little bit the role that quantum technologies will play in all of this. And then I will address the question, what can go wrong? Yeah? Because there are probably many things that can classically go wrong or artificially go wrong. Yeah? And maybe conclude with some general thoughts about sovereignty in science, academia, and what future researchers or maybe emerging researchers should do or should not do. Yeah? So let's give a look first how the scientific method is being reorganized. Yeah? It all started roughly in the 1600s with people like Bacon that promoted kind of the empirical approach to science, yeah? Not anymore the Aristotelian one. Yeah? Followed very quickly by people like Newton that from the philosophical realm moved it to the very practical, theoretical, writing down equations that model planetary motion, for instance. Yeah? Then it took a while for this approach essentially to change. Yeah? It only changed with the advent of computers, yeah? Of computational power, where we started adding numerical experiments, yeah? To the tools that scientists have. Yeah? And that moved sort of gradually into data-intensive research, yeah? Where we started looking at producing large data set, lots of statistics, and see that we discovered pattern. And this was promoted by Jim Gray, who was at Microsoft Research and tragically died before his papers were published in a kind of a sailing accident. He just disappeared and was declared dead several years later. Yeah? But now, So this is sort of the classical picture, the standard canonical picture. Yeah? But now a fifth paradigm is coming up. Yeah? And this is the AI-mediated era, yeah? In which the computational sphere is not just a machine that crunches numbers. Yeah? It's really participating actively in what we do. Yeah? So they're not only processing the data, they can even help us formulate the questions that we want to investigate. Yeah? And this is really, I think, kind of a phase transition, yeah? Something that we didn't have a few years ago. So the point is now that AI is now really a new tool, yeah? A new instrument that we have. Yeah? And you know, when microscopes were invented, yeah, people started looking at cells and they transformed biology. Yeah? But the microscope doesn't understand the cell. Like, you know, South Africa, we have lots of radio astronomy. The telescope are the instrument. They don't understand anything. Yeah? And now we are in this. We have this new tool in our reservoir, yeah? And even if AI doesn't maybe understand, or maybe it does, we'll find out, yeah, whether it's conscious or not. Yeah? It's definitely transforming the way we do science. Yeah? So, and that is really, really very important, I think. Yeah? So, why are we sort of forced to use AI? Yeah? Mainly because of this scalability problem. Yeah? It's impossible to read all the papers that come out. Yeah? It's impossible to test all substances that we would like to synthesize. Yeah? And it's really impossible for the individual to explore all the possible models and proofs and design and so on and so forth. Yeah? So that the challenge that we have now is not so much going to the library and accessing information. Yeah? It's mainly organizing it, using it to do something and act on it in a sensible way. Yeah? And this is the role that that AI plays for us. Yeah? And in this sense, the role of the scientist is a little bit changing. Yeah? I describe it here as an architect, yeah? In the sense that we need to design the scientific process. Another way could be an analogy with the scientist and the director of an orchestra. Yeah? There are lots of tools, and the scientist sits in the middle and picks what is necessary for his research. So that the role of the scientist, the picture of the scientist alone in his dark room coming up with something, I think that is a very romantic picture that will probably never come back. Yeah? So, where are the differences, yeah, between the traditional method that I call here the classical method and the AI augmented or accelerated method? Yeah? Essentially is that now research is not only 100% human, it's sort of hybrid. Yeah? We also integrate ourselves with AI tools, yeah, that help us come up with hypotheses, help us test the hypothesis, help us write up the hypothesis, yeah, and so on and so forth. Yeah. A very standard example is literature reviews. Yeah. You know, in the old days we insisted, part of the thesis literature review, but now literature review is just a line of text and pressing a button, and it comes out probably much better than many of us can do. You're shaking your You still have to read the papers, yeah? You still have to read the papers, that I agree. But it's much easier to find the papers that you might be interest for you than previously. You know, when I did my master's and my PhD, you went physically to the library. You went to these big volume that collecting all the abstracts. Then you found something. Then you went to the other volumes where then you took it, you went to the photocopier, you made the photocopy. You went to your office, you started reading, discovered that's not what I want. Yeah? And then back to the library, and so on and so forth. Yeah? That process has been significantly accelerated, yeah? And others as well. Yeah? There are also controversial aspects like peer review. Yeah? I will mention it just now. There are studies that indicate that AI-enhanced peer review produces better results. Yeah? So, but I will, sorry, I wanted to say that later. Anyway. So AI is a new research infrastructure. Yeah? The typical workflow of research, maybe in a simplified cartoon way, yeah? It's several steps. Yeah? You start with literature review, you come up with some hypotheses, you write a model or code, and then there is peer review and social consequences. Yeah? And the point that I want to make is that AI enters each of these steps, yeah, in one way or another. For instance, we discussed already the literature review aspect. Yeah? It's just the ease of accessing and finding information and selecting what must be relevant for you. Yeah? Again, when I was a student, you could go to the archive, which is one of those famous preprint servers, and read all the abstracts that were submitted every day. Yeah? Today, you can't even read the title every day. Yeah? It's just impossible. Yeah? There are, of course, dangers. Yeah? That AI can hallucinate titles, yeah? And can happen also in AI policy documents these days, as we know. Yeah? but I think those effects are probably can probably be dampened because there are specific tools just designed for that. So that, but anyway, using AI to find information is a useful thing, I think. Yeah? Yeah? But again. For you, yeah. There is the risk that that it becomes a kind of a performance of scholarship and not scholarship itself. Yeah, if you just rely 100% on automated tools. Yeah? Hypothesis generation. Yeah. Sibu mentioned she asked ChatGPT to come up with quotes. Yeah? You can ask ChatGPT to come up with ideas that you could explore to write papers. Yeah? And this leads a little bit to the AI as a co-scientist, yeah? That comes up with new ideas that you can explore. Yeah? But coming up with crazy ideas is not the same as making sure that the crazy ideas are reasonable. Yeah? Many ideas might sound reasonable, but be complete nonsense. Yeah? That's why one needs to be a little bit critical in how we deal with these things. AI in coding, this is probably one of the most promising aspects. Yeah? I don't know how many of you code, yeah? But if you code with Claude, ChatGPT, yeah? You just write a few sentences, and then there are hundreds of lines of code. Yeah? But the problem is that AI can code much faster than most of us can understand it. Yeah? And it might be not always correct. But anyway, it's another tool to accelerate things with the obvious caveats again. Yeah? This is very interesting, and I only discovered it while preparing the talk because also during the weekend the weather was not so nice. Yeah? And this gentleman, this group of people here wrote a paper this year, yeah, on a large-scale randomized study of large language models feedback in peer review. Yeah? And what came out is that the AI feedback to the referee reports induced the recipients of the referee report to make more changes in their papers, yeah, and maybe hopefully input. These were just proceedings of very large conferences with thousands of submissions. Yeah? You know, the risk is, of course, you know, we don't want AI to write the paper, AI to review the paper, and AI again to do the corrections to the paper. Yeah? And so we need to find ways to protect the reliability of the whole operation. Yeah? Yeah, this is also an interesting one. Yeah, the AI and the social process of research. Yeah? There was also this year a very interesting article on artificial intelligence as a tool to expand the scientist's impact, but to contract the science's focus. Yeah? So even if the single individual might be more powerful in his or her research, yeah, the science become a little bit more mediocre, yeah, because it's always based on kind of average of what is out there. Yeah? So this is also a problem. Yeah? But let me give you, sorry, let me have a sip of water. 3 examples, yeah? 3 recent examples where that really demonstrate that the use of AI in science, and I'm sorry that all my examples are a bit scientific, yeah. So, but I'm sure there are other examples that come from the humanities and other disciplines. This is a famous one because it's also Google related, yeah. And years ago they produced this software called AlphaFold. Yeah, that was the first time where we were able to simulate numerically in a finite time the folding of proteins. Yeah. In the meantime, there is AlphaFold 3 that can do all other sorts of of even more complex proteins and molecules and so on and so forth. Yeah. And this is very interesting because now we have softwares that can predict configurations of molecules. Yeah? It still can't explain them, yeah? But at least it can give us the opportunity to explore certain structures that might have certain properties that might be useful to implement. Yeah? So without machine learning and AI, this wouldn't have been possible. Yeah? Another example is from materials discovery. Yeah? There is also fairly recent, a couple of years ago, there's this software called GNOME that stands for Graph Networks for Materials Exploration or something like that. Yeah? And this is a software that explores new crystalline stable materials. Yeah? You still have to produce them afterwards, yeah? But at least it can give you idea of materials that are in principle possible and have certain properties that people might want for certain things. Yeah? And you know, the idea between this paper was really to show that you have this AI that suggests new new material structures. Yeah? You push them into an automated laboratory that produces them, and then the feedback loop tells you, okay, this work didn't work, I have to improve, and so on and so forth. Yeah? And it's a completely kind of automated chemistry lab, if you want. Yeah? And it's, of course, difficult to say, and this is the important point, yeah? Where does the AI rest? Yeah? Is it in the simulation? Is it in the automatic laboratory? Is it in the optimization loop of the feedback? Yeah? It's everywhere. Yeah? So it's really all coupled. Yeah? The third example is one we probably would expect it the least, yeah? Which is mathematics. Yeah? And this is also fairly recent, this paper here, but there are even more modern demonstrations. Yeah? where again, Google developed this tool called FunSearch that searches in function spaces to solve certain combinatorial problems, and suggests algorithms that were not there before, that then the mathematician can test, and all of a sudden some proofs, things get proven that nobody could prove before. So this is also very, very interesting. So what is the common feature? The common feature, I think, is really the hybrid approach, the interaction between the machine and the human, that serves to accelerate the whole complex process. And I think this, for universities, and I have a few more thoughts about university later, is that this kind of new system should also change the way we train researchers. Because maybe we are too old to learn new tricks, but our students should learn the whole repertoire of the new tricks. And probably all of you supervise students that live in ChatGPT, or in Claude, or in whatever. So we need to up our game as well. So, because I'm a quantum guy, I need to say a few words about quantum for good measure. Why are quantum technology so exciting? Essentially because for the first time in hundreds, if not thousands of years, we have a new paradigm to do computation. It's not just adding zeros and ones, or using abacus, using a CPU, they all function according to the same system. Quantum computers work according to the laws of quantum mechanics that are different from the law of Newtonian mechanics. It's all about all the spooky things of quantum mechanics, cats that are dead and alive, entanglement, superposition, all those crazy things. You use all those crazy things to do computations. And since 20 years, we know, for instance, because of Shaw, who came up with an algorithm to factorize large number into its prime component, that you can develop an algorithm that is exponentially faster than all the other algorithms that we knew before. And this is a serious problem for security, because it means that once we have a nice quantum computer, the little system with the lock when you buy something on Amazon, it's not safe anymore. So it's not just a curiosity. It's something very, very practical. Okay, we don't have yet this completely fault-tolerant quantum computers, but we are getting there. So it's something that is coming, and you can already use them in the cloud. So why does it matter for science? What we know now is that and this also goes back to an intuition of Richard Feynman of almost 50 years ago, that at fundamental level, nature is quantum. Everything is made out of atoms and molecules, and those are all quantum. So if you want to simulate the quantum world, if you had a machine that is quantum itself, it should be a good match. And now we know that it's really like that. We have this machine, these quantum simulators that are very good at simulating quantum processes, for instance, in quantum chemistry or for quantum materials, and so on and so forth. So the idea is that we can use this as a new tool in our numerical machinery. And this is also very interesting because AI and quantum are not completely uncorrelated. If we design quantum computers, we use lots of AI to improve the design and so on and so forth. But the opposite is also true. We can use quantum computers to facilitate the use of AI. For instance, in the developing of materials or quantum chemistry simulation, because you can use quantum simulation to train the AI to find out what you want to find out, instead of doing the experiment. So you can really create a very virtuous virtuous loop of combining AI and and quantum. Yeah, and I think in future, we will need lots of researchers that can jump between the two things, yeah? from the AI to the quantum side and vice versa. So, to come to an end of this part, as I mentioned before, I see it that the science workflows of the future will be hybrid. Yeah, we will have at the top our good old human judgment and and reasoning, but we will have then AI tools, high performance computing tool, quantum tool, and then maybe even AI automated experimental tool. Yeah, but it will be our role to make it all trustworthy and not completely hallucinating. Yeah? So, what can go wrong? Yeah? Lots of things can go wrong. Yeah? One is, for instance, that and it's funny that we go back to old philosophical issues. Yeah? The ambivalence between prediction and understanding, yeah? Or correlation and causation, yeah? Provenance and trust, chain of trust. Yeah? So we need to defend these three distinctions. Yeah? And 2 years ago, these two gentlemen, Messeri and Crockett, wrote a very nice paper called Artificial Intelligence and Illusions of Understanding in Scientific Research. Yeah? And the three illusions are the illusion of explanatory depth, exploratory breadth, and objectivity. Yeah? Which, in other words, if you give a very fluent description of something, doesn't necessarily mean that is a good explanation, just reads nicely, yeah? But it'd be completely wrong. Yeah? If you produce fantastic visualizations, yeah? Maybe they're just nice artistic objects, yeah? But the scientific value could be very limited. Yeah? Or if you just, computers like scores and benchmarks and things like that, yeah? You score something highly, but maybe it's completely wrong. Yeah? So we really need to stick to the fundamentals of explanation and so on and so forth. Yeah? That's and essentially we need our brain, our natural intelligence to understand the why. Yeah? So correlation and causation is fairly obvious. Yeah? One of the problems is that AI is statistical by nature, yeah, and statistics tends to go towards the average. Yeah? So you sort of intrinsically prefer the mean, while maybe interesting things are at the ends of the distribution. Yeah? So you need to be very careful with that. Yeah? So all the hypotheses that come out from AI might very often just be the result of some averaging procedure of sorts, yeah? Which is not necessarily what you always want. Yeah? This we discussed already a little bit. Yeah? It's very important if we use AI and we publish results that heavily rely upon AI to tell clearly where our claims come from, yeah? Which data we have used, which model we have used, what have we asked the AI. So we need to really be really serious about that. Yeah? So one risk that I mentioned before indirectly is the risk of fast science. Yeah? It's not just a matter of high volumes of outputs. We really want the quality. Yeah? And but blindly asking ChatGPT or whatever, write a little article for me, it won't be very good. Yeah? Maybe if you are lucky, some not so good journal accepts it, but not something to be you proud of. Yeah? And in that sense, you you don't flood the library because of the rainfall. You really flood the literature, yeah? And just pollute the science system with nonsense. Yeah? And it makes it even more difficult to find what you want to find. Yeah? So these are, I also hinted at it before, yeah? That relying heavily on AI sort of collapses the breadth of science, yeah? Because statistics always follows the center of the distribution, yeah? And if interesting things happen because of outliers, you might not find them, yeah? But another very big risk, and the Matthew effect is not something scientific, it's more something of the New Testament. Yeah? Yeah? The rich get richer and the poor get poorer. Yeah? And that's because AI is expensive. Yeah? It requires expensive infrastructure. Yeah? The subscription to ChatGPT is $20 a month. And if you have ChatGPT, Claude, the $20 a month add up. Yeah? And even if you want to buy 100,000 of GPUs, you have to be Elon Musk. Yeah? None of us could afford them. Yeah? Yeah, so there is really this serious problem that science won't become more equal, it will become more unequal because some people will have the AI infrastructure and some don't. Yeah? So just as I think my time is coming to an end, just a few words on scientific sovereignty and the future research. Yeah? I mentioned it, that AI is not a cheap game in town. Yeah? And we risk really in Africa to be cut off a little bit, yeah? Because I mentioned Elon Musk, his computer colossus has 200,000 plus GPUs. Yeah? How many GPUs that our Center for High Performance Computing have? Do you know? 10, 100,000? 30. Yeah? So we are really feeling orders of magnitude of difference. Huh? And I didn't ask you how many GPUs Stellenbosch University has, because it's probably even smaller than the CHPC. Yeah? So we have a problem. Yeah? We definitely have a problem. Yeah? So we really need really to think about becoming more computing self-sufficient. Yeah? Also considering all the geopolitical nonsense of the world in these days. Yeah? And we need to to train students and ourselves as well, not just in prompting the AI, but into developing sorry, this is not on my computer, the AI itself. But you can do it only if you have the infrastructure. Yeah? And so it's also, again, Matthew principle. Yeah? There are a few initiatives. Yeah? We have a National Center for High Performance Computing, Sandra and Irisa, yeah, and we should lobby for them to up their game. Yeah? We have NITEX, yeah, which is also a kind of lobbying because it's a consortium of all universities in the country. So it's really uniting all the resources, intellectual resources in the country to try to do something in all these computational and theoretical things. Yeah? Luckily, Africa and South Africa have embraced open science, which is probably the only tool that we have to be competitive. Yeah? And there are interesting some kind of grassroots movements. For instance, last year we hosted the deep learning in Daba in Stellenbosch, yeah? Which is kind of a bottom-up initiative to train people in machine learning and so on and so forth. Yeah? And there are plenty others. Yeah? But so, you see, the point that I want to make is that if we embrace this new scientific method, the only chance that we have to survive is to collaborate and network. Yeah? It's the only way that we have to be competitive globally. Yeah? So all these boxes, yeah, people, infrastructure, data, problem, policy, yeah, it's all interlinked. Yeah? There are many more connections than I plotted there, yeah? But it's all really integrated, and it's a kind of a loop. Yeah? And you know, some will have the infrastructure, some have the data, some have the problems, some have the policies, some have the people. Yeah? We need all to come together and try to do the best out of it. Yeah? You know, if we were to tell emerging or future researchers what to do, yeah? First is, you know, they should master the fundamentals of the discipline, yeah? Because naturally, the challenges that we face are all multidisciplinary. So before you start chatting to someone in another discipline, you should understand a little bit of your discipline, yeah? AI should be a kind of a sparring partner, yeah? Not an oracle, yeah? We need to, you know, be honest on our AI workflow, yeah? And not just generate random stuff. Yeah? Also important, we should have a basic of programming skills, yeah? Because at some stage you will ask the AI to write a code for you or an app or something, yeah? But you should be able to say, is this okay or is this nonsense? Yeah? We need to lobby for infrastructure. Otherwise, we won't be able to compete. Yeah? And we should have a good scientific taste. Yeah? Let's put it that way. Yeah? So just in one sentence, we shouldn't use AI to outsource our science. Yeah? We need to use it to help us, but not to completely outsource our research. Yeah? So, just as a last thing, I think this is probably the last slide. What do universities have to do? Yeah? In particular, if they want to go to the top 100. Yeah? Yeah? Very practical things, because, you know, university, one of our major jobs is to train people. Yeah? We need to rethink how we assess students. Yeah? Because, you know, assigning essays or things like that, those times are gone. Yeah? We will definitely have to go back to some kind of oral exams or things in class. Yeah, you know, I remember I did my master's in Germany long before continental Europe adopted the BSc, BCom bachelor system, yeah? And the degree then was called a diploma, yeah? And it was 2 years plus 2 years plus 1 year of thesis, yeah? And the first exam was after the second year. It was called the pre-diploma. And it was an oral exam with 2 or 3 examiners on everything that you learned in the first 2 years, yeah? So, maybe we need to go back to that. I'm not sure. And the library would be very full during the semester holidays. Yeah, that I can promise you. Yeah? So we need to teach AI literacy. One of the things that with our rector and in my Pro-VC job have been discussing was to introduce a co-curricular activity for all first-year students in kind of basics of AI. Yeah? And then as you progress, make it more specific to the various disciplines. Yeah? And maybe one day integrate it in the program. But we need to start somewhere. Yeah? Super important, I think, is invest in infrastructure. Yeah? Like we have a library, we need to have an AI factory or something like that. Yeah? Because otherwise we can't even teach our students to use it properly. Yeah? And also, you know, also for the university, if we want to optimize our efficiency and make use of AI, we don't want our data to be on some random server somewhere where we can't control it. Yeah? We want maybe to have it in-house, yeah? And analyze it with our computational power. Yeah? And of course, we need to remind people that ethics also needs to be reviewed a little bit. Yeah? There are new aspects that we didn't have a few years ago. So, just concluding, yeah? I think all of us are kind of architects now in the future, yeah? Because we need to orchestrate and direct all these tools that work together and learn how to interact in a hybrid world, yeah? It will probably take a while until we have an AI chip implanted in our brain, yeah? But people are working on it, yeah? So that might come as well, yeah? But we need to start learning how to use these tools to accelerate our research, yeah? So thank you very much.
Thank you, Professor.
Pleasure.
We've got a couple of questions from our attendees online, and we'll also give an opportunity for questions from the audience. So could I relay some of the questions to you?
Please.
Thank you. Okay, the first question is, what does the new scientific method mean for the classical science-humanities divide?
Very interesting, but you know, we are using large language model, yeah? So language is core, yeah? And I believe that as we can sort of outsource more steps of the scientific activities to machines, we need to learn more aspects of our good old humanities, yeah? To train our critical skills, yeah? And not mess it up ethically, yeah? And also there's also the trivial aspect that also the humanities and social sciences can make use of AI. Yeah? Just think of the of law. Yeah? Lots of uses there. Yeah?
Right, and I believe you can interact on DNA sequences through natural language processing as well these days through deep learning models. So there's a lot of similarities happening between the science and the humanities. Thank you. The next question is, with less data available, can neurosymbolic AI actually close the gap with large neural models? Or does it just shift the bottleneck to knowledge engineering? So for those of us who are not familiar with the term neurosymbolic, that refers to machine learning and symbolic AI combined in a knowledge model.
No, that is, you know, I had the example of AI for mathematics. That's what those people are also trying to do, yeah? To embed the symbolic approach in the AI approach. Yeah?
Yeah. To make facts more evident and not just predictive. So that's a good example.
I mean, there are mathematical AIs to develop proofs, yeah? And those follow just, you know, symbolic procedures. Yeah.
Yeah. All right. Yeah. I'll do two more questions online, and then we'll take questions from the audience. What does this all mean for postgraduate studies and research in general when academics themselves are divided on what's acceptable in AI research? Where do we draw the line on acceptable practices?
You know, as long as what comes out is correct, yeah, that should be okay. Yeah, yeah. You know, each of us have postgraduate students or even undergraduate students. They live in ChatGPT, just to name one as a representative. Yeah, and we need to catch up. Yeah, because you know, when I was studying, people started using Mathematica. Yeah. And you know, those that were not used to use mathematics, which is a symbolic manipulation kind of thing for mathematics, yeah? The older generation were looking at them very skeptically. Now nobody talks about it anymore. Yeah? If you need to solve something, you use Mathematica, that's it. You don't even have to reveal that you used algebraic systems, computational algebraic system to solve your mathematical problems. Yeah? It's just a standard tool. Like you wouldn't declare that you use a pocket calculator to add 3 numbers in your paper. Yeah? And eventually we will get there. Yeah? You know, when I was in high school and the first Hewlett-Packard Texas Instrument things came out, the maths teacher were in revolution mode. Yeah, they thought, all these kids will never learn anything anymore. Yeah? But I think we still learned a few things.
All right, one last question from online, then we can take questions from the audience. It was touched on at the start, but in your view, how does the use of AI systems in research development and academic writing influence ownership of research?
Yeah, you know, I think there are also studies that show that, you know, if you start writing a paper using ChatGPT and say, okay, and afterwards I fix it myself, yeah, the result is much worse than if you start writing the paper yourself and then you embellish it with a little bit of ChatGPT. Yeah? So at the core should still be a little bit of natural intelligence, I fear. Yeah?
Right. Thank you. We'd like to know if there are follow-up questions from the audience, and if we can have a second mic just for roaming. Thank you.
Hi, Francesco. Thanks very much for a very interesting talk. And one thing particularly resonated me, because it's a thing what I'm grappling with as well, is how do we train students in this new reality, right? And as you say, the students live in these large language models. But, I mean, I've come across attitudes in students quite regularly, though, where the main objective is perhaps not necessarily to get to know the subject, but to pass the exam and get the degree.
Yes.
Right. So I resonate completely with what you're saying about changing our assessment policies and having more oral exams, etc., etc. That can all work. But the problem we're facing with at this university, and you will be aware of that, is massification. So we have 1,000 first-year biology students. We've got on the order of 1,000 first-year chemistry students. Yeah. And even my third-year biochemistry module that I'm teaching at the moment, we are sitting with 150 students at third-year level. So how do you deal with that?
We will use a language model to train your avatar. And your avatar will test the students, yeah? Which is what happens already in big companies. Yeah? In big companies, you know, the usual suspects. Yeah? They are trained by the avatar of the CEO, and the avatar of the CEO takes the exam. One solution. Yeah. No, but you know, I mentioned the joke of when I was studying, by reducing the number of oral exams, you also solve maybe a factor of 10, yeah? By doing maybe just one oral exam every couple of years. Yeah?
Thank you very much for the talk. I found it very interesting. On the note of AI that doesn't need human consciousness to transform, progress, or understand science, if you apply this lens from like AI implementations in, like, let's say, a corporate environment, an institution, that for me means that work results are increasingly becoming products of AI consciousness, which is ultimately adopted as a productive by human legibility. So, as people, we can't dispute this notion of productivity. The question then is, how should normative claims around stakeholder rights or corporate social responsibility, or another phrase, worker inclusivity in institutions, be approached in the relationship between the different sums of human productivity and AI productivity?
That's an essay for ChatGPT. Now, you know, there are probably many aspects, yeah? And, you know, I don't envision that we will give AI the responsibility to solve all our institutional problems, yeah? And all our employee-employer relationship, yeah? I think it will go in another direction, yeah? There was very recently a very interesting blog by Jack Dorsey, yeah, who was the founder of Twitter, yeah, and now runs some other company called Block, I think, yeah, who explained why he fired half his staff. Yeah, and it's actually very interesting because, you know, it starts with the traditional companies, yeah, hierarchical structure, yeah, which goes back to, I don't know, thousands of years. The Roman army was also hierarchically structured, yeah. And what is ultimately the reason for the hierarchical structure of institutions? Yeah? It was ultimately the information flow. Yeah? You start with a small group at the ground, they have a representative who speaks to the higher ups and so on and so forth, and then down back, and in between you lose half the information probably. Yeah? We can circumvent that today because you can create a digital twin of an institution. Yeah? And then everybody can access whatever information they need at any time. Yeah? So I think going forward, the hierarchical will be swapped with the workflows. Yeah? It makes more sense to model workflows than hierarchies because you don't need hierarchies to share information anymore. Yeah? You can. That's what these companies do. Where you read they fired half the staff and so on and so forth, but they still work. Yeah? And again, the first one was Elon Musk. Yeah? He bought Twitter, fired half the people, and Twitter is still there. It's called X, but it's still there and thriving. Yeah? So many things will change. Yeah? Whether we like it or not. Yeah? But maybe not necessarily for the worse. Yeah? Because you know, if all the information in a company is accessible to everybody at every time, yeah, it sort of empowers everybody, yeah, instead of disempowering them. Yeah? I mean, we will feel sorry for those that get fired, but I'm sure that they'll find some other opportunity. Yeah? They can start a one-person company, and that works as well. Yeah?
Thank you.
Pleasure.
Thank you. We can take one last question, and then I'm afraid our time is up. If there are any more questions, Ellen, thank you.
Francesco. And just a comment on the literature review. And yes, indeed, I can confirm that it is so time-consuming, and we've certainly found over the last couple of years that there is an increase in the demand for these literature reviews. Of course, it differs from discipline and faculty to faculty. And yes, so we have now responded to that, and we have actually acquired now also the library of an AI tool for that, Ryan AI, and we are currently in the process of rolling that out, because we noted the intervention from the library side compared to the number of reviews that are actually published by SU researchers are huge, and that we found out that they use the free version of this tool. So that's definitely coming, and we're sure that is the future. There's no way that we can spend the amount of time that we do to assist with manually and even using other databases to do so. So indeed, that's what we're working on.
Excellent, thank you.
Thank you. I would like to hand over to Nokupiwa for a word of thanks.
Thank you.